Ashwin, good evening, beta. Just one minute, I'm going to start. Kanishka, good evening. Sharmila, Divyashri, good evening. Good evening, Bacha Party. Just 1 minute. Ayyo, again it got stuck. Shruti, Divya, Sharmila, good evening. Just 1 minute. Good evening, beta. It got so badly stuck. It's not coming. Last class we were talking about Vishal, good evening. Just give me 1 minute. Yeah, just give me 1 minute. Let's start the class. Fine. Ayo, it is looking so difficult to it's looking. Now check, is it okay? So last class we were talking about Rutherford model of Rutherford experiment. In that thin gold foil examples we were talking about. Now shall we go for the next one, beta? State reason for Rutherford to choose alpha particle for scattering and gold foil as a target to his alpha particle scattering experiment. This is a very important question. If somebody will be telling you what is your name, then 100% you are going to say that this is my name. But if somebody will be telling you why Rutherford choose this experiment, then 100% this will be a bit problematic to answer the question, because here one small thing is there. Just for 1 minute, like state why Rutherford choose this alpha particle. First, alpha particle selection, Rutherford alpha particle selection. What was the reason behind selection of alpha particle, and what was the reason behind selection of thin gold foil? This is exactly the question. The reason behind selection of alpha particle. See, he has not woke up one day and said, now today we are going to use alpha particle for experiment. There must be some reason behind. There must be some reason behind selection of alpha particle. What is the reason behind selection of alpha particle? Come on, quickly tell me. What is the reason behind selection of alpha particle? Good evening, Ekta. Good evening, everyone. Now come on, tell me first answer. I'm very keen to know what answer is exactly going to be. Ashwin, he chose gold foil because it can be turned into thin sheet. Fine. Very good, Ashwin. That was a very intelligent answer. So Ashwin has done a research in that, and he exactly came up with this idea that yes, he has used thin gold foil. The reason behind selection of thin gold foil is that it is exactly what you call, it can be, because we know that gold and all, Madhav, the gold foil has less number of atoms compared to others. Yes, he has taken 1000 atoms only. If we will be talking about, he has taken only 1000 atoms in that gold foil. So this can be one of the reason behind. Fine. Either the numbering is fine, it's looking like bit ulta, so I'm going to just make it big. Fine. What is the next question? Next question, what is exactly the Madhav, this thin gold foil? Okay, fine. Next part, why he used alpha particle? See, rather than that alpha particle, he might have used anything else. So the major, what is the major reason behind using alpha particle? What is the major reason behind using alpha particle? He could have used anything else, but he only used alpha particle. What is the reason behind using alpha particles? Reason behind using alpha particles? The gold foil has less number of atoms compared to others. Okay, only alpha particles. See, mostly his experiment was backing J.J. Thomson experiment, and J.J. Thomson has proposed one very important point, Naresh. I think Madhav is Hari Keshav. Madhav is Hari Keshav. Okay. So now look here. Thin gold foil selection is exactly one of the reason for see. First, go to J.J. Thomson experiment. In J.J. Thomson experiment, J.J. Thomson said one very important point, and that is like atoms are electrically neutral and number of positive charge is exactly equal to number of negative charges. Fine. So this is the one point. Okay. So I think Rutherford has kept this point as consideration. And he was expecting, because look here, see, one very important point is कि when something is scattered, then the very heavy positive charges, now very heavy positive charges, he's your friend, okay, then heavy positive charges are exactly going to pass the thin gold foil without scattering. Fine, it will pass the thin gold foil without scattering. His expectation was that like all the heavy alpha particle, because alpha particles are also positively charged and the atoms are exactly having positive charges, and according to J.J. Thomson model of atom, J.J. Thomson has also proposed the same thing, that the positive charges are scattered in the structure. The positive charges are what? The positive charges are scattered in the structure very nicely. And then this is what na ki if a very heavy positive charge will exactly going to pass through the structure where the positive charges are scattered, then this scattered positive charge will not have that much impact on this positive charge, and the positive charge will cross this area without showing any deflection. But unlike his concept, the things went very different. What happened is, his conception was this only, but reality, this is called as concept versus reality. So here concept was like that, but reality was totally different. What happened in reality, that some of the rays went past, but some of them exactly made some angles and malleable and ductility is property of metal beta, but the most important thing here is, yes, that is what. So when you can beat something into thin wires and thin sheet, that means what? Thin sheet, then it is exactly going to allow. So that the most important concept was that the positive charges that was scattered on the structure. See, J.J. Thomson, if somebody will be telling you that, okay, this is the concept, so you are going to carry that concept and you are going to prove that concept correct. So same thing, Rutherford tried to prove J.J. Thomson concept correct, and for that only he did one small work, and that is he allowed very heavy alpha particle rays to positively charged alpha particle rays to pass through the thin gold foil. His expectation was like all the rays will pass undeflected, but concept versus reality difference, I told you here the reality was totally different. What exactly happened there, that it exactly made some angles and it exactly went deflected and made some angles. So this was exactly the proving that no, the positive charges are not scattered nicely, it is concentrated somewhere. And then he came into conclusion that okay, each and every atom has a positive charge center, and it is exactly a very small portion of it, because out of 12,000 rays, only one ray. Yes, that's what. No. The thing here is कि you will be taking helium atom now. When you will be taking helium atom, then that time helium atom is neutral. Helium atom is neutral. So you have to understand one thing, that you have taken helium atom is neutral. Then what you have done is you have taken two positive charges, means two electrons from. See, I am stable right now. That means I don't need anything from you. Okay, so that means what? I'm stable, I'm not wanting anything, I'm quite satisfied. So I'm stable right now. But one thing what I'll do is, you came and you picked two electrons from me. So see, initially what happened, the structure is a stable, it is exactly having, exactly helium is there. Now from helium, two positive charges you have taken. Since two positive charges you have taken from helium, now helium is not stable, it is highly unstable, because from here you have taken two electrons and now it is having a very high penetrating power. Okay, the one which was stable was helium atom. Okay, and the one which is exactly having a high penetrating power is this one, and it is exactly having a high penetration power, a very high penetration power, and it can penetrate to the thin gold foil, and it can penetrate to what? Thin gold foil. I hope you might have understood this concept. Okay, so now let's go back to the content now. So what is the answer given? So alpha particles for scattered of his experiment, because alpha particles are doubly charged helium ions. I hope, Dev, you might have got this point, that alpha particles are doubly charged helium ions. They are not atoms. First, and second says they have a mass of 4u. The fast moving alpha particle have a considerable amount of energy, and they are quite active, and they have a high penetration power. They have what? They have a high penetration power. So shall we go back to the next question, please? He selected gold foil as a target in his experiment because this gold foil was about 10,000 atom thick. Okay, so now J.J. Thomson model of atom, it is sometimes in question they will be asking that draw the structure of J.J. Thomson model of atom. So J.J. Thomson model of atom, just always remember watermelon. In watermelon, seeds are there na. If you will instead of seeds, if you will put positive charges and negative charges are scattered all around it, then it is exactly called as J.J. Thomson experiment model of atom. So Thomson model explained that atoms are electrically neutral. Okay, the result of experiment carried out by his scientists, other scientists could not explain by this model. So we already know about this point. Now shall we go for the next point? I think we have done this point. Next question is the quality of video is very bad today. Now look here. Now next important question is it came in your exam. That is a very important question right now. Now look here. Question is describe Bohr model of atom. If somebody will tell you describe Bohr model of atom, instead of electron you wrote neutron. No, the correct answer will be exactly electron positive charges. The correct answer will be positive charges only. Okay. The correct answer will be positive charges. So shall we go for the next question? Describe Bohr model of atom. So I think we have discussed about Bohr model of atom. Bohr model tried to stabilize the structure of atom. The most important focus for Bohr model of atom was to give a perfect stable structure of atom. To give a perfect stable structure of atom. That was the concept of Bohr model of atom. Fine. Come on, tell me the answer. What was the postulates? Describe Bohr model of atom. So write the postulates about Bohr model of atom. We have already discussed the postulates of Bohr model of atom. So I am really keen to know the Bohr model of atom. Come on, quickly tell the answer. Bohr model of atom. Bohr model of atom. Write the postulates about Bohr model of atom. This question is very important. This question is very important. Or state the major drawbacks in Rutherford model of atom. Mention two features of Bohr model of atom which helped compensate this drawback. So what are the two features of Bohr? Shrutika, 2n square rule. Very good, Shruti. See, I really want some very focused answer, cut to cut, point to point answers. So if you are giving answers, so please kindly make sure that you are writing from the beginning the most important point to the least important point. So just select the most important point and then go from most to least. So first point is Shrutika is telling 2n square rule. Very good. So 2n square rule is exactly talking about the placement of the electrons in the orbits. Very good, Shruti. Then Kanishka is getting Bohr model consists of a small nucleus surrounded by negatively electron moving around the nucleus in orbit. Ashwin, known as shell or orbit. Okay. Ashwin, the atom consists of a small positively charged nucleus at its center and surrounded by negatively charged electrons in definite circular path. Fine. Ashwin, the nucleus controls all the protons. The nucleus contains all the protons and neutrons of the atom. Absolute here. Fine. Okay, fine. I understood the point, what you are wanting to say, that exactly this is the most important point for an atom description. So if somebody wants to explain an atom, then they will be saying that an atom is exactly having nucleus at the center, and the nucleus is positively charged, and inside the nucleus neutron and proton is there, and the nucleus, the entire mass of the atom is concentrated at the nucleus. So this is about the most important point about nucleus, what Bohr has exactly postulated. Bohr talked about that, okay, fine, the structure is exactly having nucleus, and nucleus is concentrated at the center. It is exactly containing neutron and proton. It is positively charged. It is having mass, and then entire mass of the atom is concentrated at the nucleus. Fine. This was the point. K element, that is 1, 2, 3, 4. That is, and that the 2n square rule was there. So 100% Shruti has already explained that point. Sharmila, proton and neutron are present within the nucleus. Due to presence of proton, the nucleus are positively charged. Well done, girl. That's the most important point. Fine. That's the most important point. Because of that, exactly, it is positively charged. Very good. Shall we go back to the next important point, please? Come on, focus to the next important point. Now here, what was the drawback of Rutherford model of atom? What was the drawback of Rutherford model of atom? If I will be saying that what is my drawback, then I'll say that I am very short tempered. Then this is my drawback. Means what? Means the quality is called as what you called advantage, and what you call, and what is the disadvantage or drawback. So here we are not talking about this, here we are talking about drawback. So what was the drawback? What was the drawback of Rutherford model of atom? The most important drawback of Rutherford model of atom. Come on, tell me. The most important drawback of Rutherford model of atom. The most important drawback of Rutherford model of, it couldn't explain as stability. Very good. So can you precisely tell me what the stability of atom means for you, Shruti? Because he explained everything. I think the major points Rutherford explained very nicely, that definitely it is having a center. The entire mass of the nucleus is entire mass of the atom is concentrated in the center. Nucleus is positively charged. All good qualities were there. Spectrum of the atoms, J.J. Thomson has given the hydrogen spectrum of atom, and that is exactly the different spectrums are there. P found bracket, and their different spectrums are there. Balmer, Paschen, bracket, P found, their different spectrums were there of hydrogen, and that is a different thing. But here we are going to talk about Keshav, Hari, Madhav. I'm just talking about another important point, and that is exactly what was the limitation of Rutherford model of atom. What was, if you talk about drawback, then what was the major drawback of Rutherford model of atom? So Rahul is telling, a rotating electron normally will spend its energy and fall into the nucleus. See, the major drawback was its structure. Okay, see, everything planned nicely, but the most important thing is the structure. So when that structure itself will be wrong, then how can we say that the atom can be existing? So the most problematic structure was, he has given a spiral structure. No stability was there in the structure. The reason behind it, given electron will revolve in the own orbit, then it will be means it will not release energy. But since the electron will revolve in the spiral structure, the more it will go near to the nucleus, the more it will radiate energy. And what will happen? The structure will keep on becoming small, means it will keep on radiating, and one time will come when it will fall into the nucleus and the structure will collapse. So this is exactly about stability. The structure will collapse. So once the structure will collapse, means what? Atom cannot exist. But is this the fact that atoms cannot exist? No, this is exactly a stupid concept. Atoms are existing. Atoms do exist. Atoms are existing. Okay. Yes, it will fall into the nucleus. Atoms are existing. So, but according to Rutherford model of atom, if we will consider Rutherford model of atom, that means the structure is not existing. It will fall into the nucleus. It will do what? It will fall into the nucleus. So this is the biggest demerit. Fine. Spiral structure was the defect there actually. Fine. So state the major drawback. So let's see what is the Bohr postulated to overcome the drawback to Rutherford model. Okay, that are follows. So Rutherford model already we have discussed. In an atom, the electron revolve around the nucleus in certain definite circular orbit. These circular orbits are called energy cell or energy level. An electron revolving in a particular orbit has a fixed. This is what the points we have already discussed. So this is exactly the Bohr postulate. This is exactly what we are discussing about the Bohr postulate. Just Bohr overcome the defects of Rutherford. Come on, Rutherford has exactly given a spiral structure. Bohr has exactly changed it, and he is now making circular structures. And then he told that, okay, fine, electrons are revolving in a particular orbit, and if electrons are revolving in particular orbit, they do not radiate energy. Fine. So, but Rutherford told that okay, the structure will be spiral. So what will happen if the structure will be spiral? When the structure will be spiral, then what will happen? The more the electron will go near the nucleus, the more it will start releasing energy, and one time will come when the electron will fall into the nucleus, and this is exactly the most important drawback. Fine. And this drawback was overcome by Bohr. Okay, that means I will do a mistake and you will cover up my mistake. This is exactly Bohr has done for Rutherford. The orbit, I hope you might have understood this point. I hope you might have understood this point. Come on, Ashwin. Ma'am, when electrons are revolving around the nucleus, it attains the acceleration and it loses its energy and charge and give to nucleus. He failed to explain the stability. Yeah, actually stability point, see, look here, atom, electron in a particular orbit. Now Ashwin, you have to understand one thing. Yes, electron is having acceleration, it is exactly having energy, but the most important point is ki when electron will be revolving in a particular orbit, that time it is not radiating energy or losing energy, but in the spiral structure it was losing energy, and finally the structure was getting small and small. One case will come when it fall into the nucleus. According to Rutherford model of structure only, we have a Rutherford structure of atom only, we are considering this point. Rest other, don't think about it, don't think too much, just go back to the point. Okay, don't think too much, just go back to the point. Okay, so his structure was wrong. That was the most important point, that his structure was wrong. Okay, so when he and that structure clarification means that structure what you called that structure change was done done by Bohr. I hope you might have understood this point. Yeah, his structure was wrong. We'll go back to next point. Now the electron, so one more question is not coming. So identify this one and tell the name of this. First tell me the name of this atom. Now do one thing, that identify which one is Mg2 plus ion. Okay, identify Mg2 plus ion from this, where neutron and proton represent the number of neutron and proton respectively. So here number of neutron and proton is exactly present. Here number of neutron is 12, number of proton is also 12. Here number of neutron is 12, number of proton is 10. So which one is exactly going to represent Mg2 plus? We have already have discussion about it. So which one is representing Mg2 plus? The one which is representing Mg2 plus is this one, because here you know that in the nucleus number of proton equal to number of neutron. Number of proton equal to number of neutron in an atom, but in an ion, okay, in an ion if we are going to talk about, one mistake is there. Okay, fine. Identify Mg2 plus ion from figure where N and P represents number of neutron and proton respectively. Okay, fine. I'm just keeping my mouth shut for a minute because I speaks a lot. I'm going to keep my mouth shut for a minute. You are going to tell the point. Yes, that's what I told. I am going to keep my mouth shut for a minute because here proton number is getting changed. That's what a very important point here, and so only I kept my mouth shut, and that's why I said that I speak a lot nonsense. Now carry forward for this point. What answer we are expecting here? Because here nitrogen is 12, proton is 2, nitrogen I'm saying, neutron is 12, proton is 12, neutron is 12, proton is 10. So here now you have to check that what is the atomic number of magnesium. Go for the atomic number of magnesium. Once you will be going there, you will be taking out the most important point. What is the atomic number of magnesium? Come on, quickly tell me. 12. So what could be the mass? Okay, come on. What could be the mass? If atomic number is 12, what could be the mass? If atomic number is 12, what could be the mass? Come on, we will go from that. See, sometimes what happens, when we are not getting the answer directly, we have to take the indirect content and we have to check. So now tell the point here. Now which one is giving mass? Which one is giving mass? Which one is giving mass? The first one or the second one? So which one is giving mass? Just check the one. Check the one which is giving the mass. So Shruti, what could be the answer? Check the one which is giving you the mass now. Change of concept done? Fine. So now let's see. Check. Oh, electron and proton also you have to be countable. Electron and proton has also to be checked here, dear. So here 3-4 options were there. So first and second option I have showed you. Now I am third and fourth option I am showing you. First and second I have showed you. Third and fourth option I am showing you. Now come on, check mass and electron. Mass and electron. Mass and electron. I am going to show you the structure first. I gave you the entire clue here. First thing is that number of electron equal to number of proton. That is exactly for atom. So the most important thing is here that the moment I saw that point that proton number is changed, I told you that I speak a lot nonsense. So I have to keep my mouth shut for a minute and I have to just check the content one more time. And then third and fourth option I have showed you. Now why fourth option is going to be the correct answer? First thing is that atomic mass we got is 24. What is the atomic mass of magnesium? The atomic mass of magnesium is 24 and we do got here 24. Come on, check this one out. It is 12 plus 12 is coming as 24. That's it. 24 we got. Now here the next important point is electron number, because we are not searching magnesium. The most important search here is which one is more important for us, we have to decide. So now look here, magnesium 2 plus is there. So magnesium 2 plus. So we are not searching magnesium. We are searching magnesium. Absolute correct, Madhav. You nailed it here. So here magnesium 2 plus means number of electron will be 2 less than. Come on, have a look here. So here in the first orbit 2 electrons are there. Then 3, 4, 5, 6, 7, 8, 9, 10. Story ends here today. The thing here is when you are talking about this one, it is exactly containing only 10 electrons. It is exactly containing how many electrons? Only 10 electrons. So there number of proton is 12, number of electron is 10. So since number of proton is 12 and number of electron is 10, which is 2 less than the number of proton, that means 100%. This is our search ends here. This is our final answer. Fine. So we had 4 options. We killed all the 3 and we got the 4th one. Fine. So now we will go for the next question. The next question is, how will you determine the maximum number of electron that can be accommodated in a particular shell of an atom? This is exactly a different type of question. You have. Now, how will you determine the maximum number of electron that can be accommodated in a particular shell of an atom? What is the rule through which we are going to determine it? Come on, you can do it. What is the rule through which you are going to determine it? One small thing, and that is 2n square rule. Absolute. That is 2n square rule is the rule which is exactly determining how many electron can be accommodated in which particular orbit. Okay, how many electron can be accumulated in which particular orbit, and this is exactly called as 2n square rule. Come on, where we are running away? We are exactly finding that 2n square rule, and according to 2n square rule only it is exactly coming as fine. Everyone is absolutely correct. Pakka answer you are giving today. So here, yes, the maximum number of electron that can be accommodated in a particular cell of an atom is given by the formula 2n square, where n is the orbit or the cell. And one more important point to be noted. Whenever we start filling electron, we fill electron from lower energy level to higher energy level. So the more we will go out from the atom, the energy level keeps on increasing. So the near one to the nucleus will be having lower energy level. The one which will be far away from the nucleus will be having higher energy level. So this is a very important point. Always children are having confusion that, auntie, the one which is very near to the nucleus now, it is having very high energy level. You know why? Because it is very near to the nucleus. No, it's not the truth. The truth is the one which is exactly very near will be lower energy level. The one which is very far will be higher energy level. That's it. That's the only point. Okay. So shall we go to the next question, please? The electron. So now next is the electronic configuration of potassium is this. Instead of 2 at 9, though the M shell can accommodate up to 18 electron. Explain. This is a very supernova question, and this answer I am expecting from you. Very nice answer I am expecting, because this is the real content. If you will answer this, one chocolate is pakka for you. Fine. So just give me this answer. Just give me this answer. What they are telling here that. So I'm sorry I'm saying it. Hey, where is the chocolate girl here? Huh? Yes. See, that is what Shruti, one day I taught that it is exactly penultimate, anti-penultimate. So first it is 2, 8, 18, like that concept is there. But Bohr scheme says that 2, 8, 8. So there are certain things like SPDF rule is there, Shruti. So that SPDF rule in class 10th you are going to study, or higher classes you are going to study. With the help of that, now Shruti, you will be able to know that first we are filling the lower orbital, lower energy orbital, and then higher energy orbital. So inside the cell, orbitals are there. Inside the orbit, orbitals are there, and we are naming it as SPDF. What we are naming it as? SPDF, and there are certain rules for filling it. So only. But here my question is not that one. My question is the electronic configuration of potassium is 2881 instead of 289. Though the M cell accommodate up to 18 electrons. And see, Ashwin is very clever. He told my point to me only. Super, Ashwin. Very good. I am clapping for you. This boy is so clever enough. He gave my point to me. Super, Ashwin. Madhav is telling, according to octet rule, its cell has 2 electron and remaining cell has 8. Then the electronic configuration is 2881. So first we are going to fulfill the lower energy level to higher energy level. So what answer we are expecting here is, exactly look here, this is because the outermost cell can have a maximum of 8 electron only. Understood? So this is the basic part of it. That the outermost orbit cannot have more than 8 electron in the beginning, and then it will give some electron to outermost orbit, and then again we will jump inside. That is called as penultimate and anti-penultimate conditions. So that is penultimate, anti-penultimate cells are there, that you are going to study in higher classes. But here according to Bohr scheme, what you have to remember is okay, the electrons will start filling slowly. First 2, then 8, then 8, and then 1. Why? Because it is the maximum content, the maximum number of electrons we can expect is 8 only. The maximum number of electrons we can expect is how many? 8. I hope you might have understood this point. Come on, shall we go back to the next question? Fine. as assertion reason questions are not going to come for you, so we are going to see the question. State two important postulates of Bohr model of atom. We have already seen postulates of Bohr model of atom. So it has two electrons. So this is a, see, exception is there for the first orbit, because first orbit is lower energy level, and first orbit according to 2n square rule can accommodate only 2 electrons. According to 2n square rule can accommodate how many electrons? Can accommodate only 2 electrons, not more than 2 electrons there. Fine. Now 3 marks question we are going to see. The first 3 mark question is, I hope you might have understood, Madhav P has 6. That is what Madhav, it is called as SPDF rule. SPDF is spin quantum, that is spin quantum, that S will be exactly having 2, it can accommodate 2 electrons, P can accommodate 6 electrons, D can accommodate 10 electrons, and F can accommodate 14 electrons. I hope you might have understood this point. Shall we go back to the next question, please? So now our next question is, give reason for the following. I want a pakka reason for here. Okay, pakka means very important reason only you are going to give it to me. Otherwise, don't give me. So give reason for the following. Ions are more stable than atoms. Ions are more stable than atoms. Ions are more stable than atoms. What is the answer you want to say? Ions are more stable than atoms. Who is going to give the answer? Ions are more stable than atoms. Ions are more stable than atoms. What answer you are going to say? Ions are more stable than atoms. What answer you are going to say? One are formed with atom gain or loss electron to achieve the electronic configuration of its nearest inert gas. So ions are more stable than atoms. Naresh, pakka point. I was wanting pakka point. You gave me pakka point. No more complaints. The thing here is the answer is absolutely correct. You know what? Atoms now, they are electrically neutral. Means number of positive charge will be equal to number of negative charge, but they are not stable. You know why? Because they may either have more electrons in the outermost orbit, which we are calling it as or they have less. So when they want, and all the atoms now, they either want to gain the near, see, all of them want to become like what you call noble gases. Means they want to attain the nearest noble gas configuration. What they want to attain? They want to attain the nearest noble gas configuration. Since they want to attain the nearest noble gas configuration, so what they are exactly doing is either they are taking electron or they are giving electron. So what they are doing is either they take electron or they give electron. So when they take electron, they want to become stable. So how many electrons they will be needing? They will take, so that will become negatively charged. How many electrons they have extra, they will give, so they will become positively charged. So in both the cases, they give electron, they take electron. In both the content, when they are giving electron and taking electron, they are exactly stabilizing themselves. Okay, so that's why ions are more stable than atoms, because atoms do have extra electrons which they can give, or less electrons which they can be needing to take to gain the nearest noble gas configuration. I rest my case, sir. Shall we go back to the next question? Noble gases show low reactivity. This is the most important question. Why noble gases cannot show reactivity? Why noble gas is not showing any reactivity? They are exactly very silent and very like they'll always be resting. Fine, I am very restful. So now, ma'am, can you keep both cases at morning? I didn't understood. Valency is 0, absolute. Correct, Madhav. The correct answer is yes, its valency is 0. That means what? They are exactly inert. Inert means stable. Its valency is 0. They don't have extra electron and they don't lack electron also. Means how many electrons needed to fulfill the octet rule? That valence electrons are exactly present there. Valence electron means the electron present in the extra nuclear, that is the outermost orbit. So since they were whatever how much electrons they will be needing, that much electrons are exactly present there. Because of that, they are exactly stable. They are what? They are stable. Fine. So shall we go to the next question? An atom is electrically neutral. So atom is electrically neutral. What does electrical neutrality means? Can you explain this point? An atom, noble gases have fully filled valence cells. Absolutely. That is, the valence electrons are exactly satisfied. They can't take, they can't give. So since the valence electrons are satisfied, so only they are stable. Very good. Rahul, that because they have zero valence electron, zero valence electron, or valency is 0. Valency is 0. Okay. Okay, classes. Vishal, you want both the classes in morning. Electrons are balanced by protons. Electrons are balanced by protons. Electrons are balanced by proton. That is electrical neutrality. Yes, that's the perfect word what we can use here, Madhav. That is the number of positive charge and the number of means the number of electron will be equal to number of proton. Because of number of electron equal to number of proton, atoms are electrically stable. Atoms are what? Electrically stable. Fine. So we are exactly going to go back to the next class. So tomorrow you have one offline class, one online class. Morning you I think tomorrow you will be having 3 classes. So tomorrow we will be having 3 classes. I'm just going to schedule the class and inform you. Bye.